Inside this tiny piece of silicon lies one of humanity's greatest engineering achievements. Every second, billions of devices communicate across our planet. From your smartphone to advanced artificial intelligence, nearly every modern invention depends on one remarkable piece of technology: the computer chip. Even a single particle of dust can destroy a chip. That's why these factories are cleaner than most hospital operating rooms. It may sound unbelievable, but every advanced processor begins with one of Earth's most common materials: ordinary quartz sand. Every computer chip begins its journey here. Deep inside massive quartz mines, workers extract one of Earth's purest natural sources of silicon. Thousands of tons of quartz are transported every day, beginning a transformation that will eventually power billions of electronic devices.
The raw quartz is crushed, washed, and carefully cleaned, removing unwanted minerals before the purification process begins.
Inside giant electric furnaces, quartz is heated above 2,000 degrees Celsius, separating pure silicon from oxygen. Raw silicon isn't clean enough for electronics. It must be purified until it's nearly perfect. The thermal gradient is stabilizing right on target.
Yes, the diameter control looks excellent.
The pull rate is holding steady. Data confirms flawless growth. We are clear for stage 2. This giant silicon crystal may look ordinary, but it will soon become thousands of powerful computer chips. Diamond wire saws slice the crystal into incredibly thin wafers, each one cut with microscopic precision. Each wafer is carefully ground until it reaches an almost unimaginable level of thickness accuracy. Chemical and mechanical polishing removes even atomic-scale imperfections, creating an almost perfectly smooth surface. Even the smallest contaminant can ruin an entire chip. Every wafer is cleaned using water that is purer than drinking water. The AI is highlighting a repeating defect pattern here in the peripheral die. Yes, I see it. Let's initiate a level 2 analysis on the next rotation.
Welcome to the fabrication plant, or fab, where billions of microscopic transistors are built with astonishing precision. Human hands rarely touch the wafers. Intelligent robotic systems move them automatically between hundreds of manufacturing steps.
These rooms glow yellow for a reason. The lighting protects special light-sensitive chemicals from being exposed too early. A light-sensitive material called photoresist is applied in an incredibly thin and perfectly uniform layer. The wafer is gently heated to strengthen the photoresist, preparing it for one of the most precise manufacturing processes ever invented. Now the wafer enters the heart of the factory, where light will carve patterns thousands of times smaller than a human hair.
This extraordinary machine is among the most advanced ever built, capable of printing features measured in just a few billionths of a meter.
Instead of using ordinary light, the system fires powerful lasers at microscopic tin droplets, creating an intense burst of extreme ultraviolet light. Because this light is absorbed by glass, it travels only through a vacuum and is guided by mirrors polished to astonishing perfection. The circuit design is stored on an ultra-precise photomask, acting like a microscopic stencil for the chip's intricate architecture. Extreme ultraviolet light transfers billions of microscopic transistor patterns onto the wafer with astonishing precision. The exposed photoresist is developed using specialized chemicals, revealing the first microscopic blueprint of the future processor.
Powerful plasma removes exposed material atom by atom, carving microscopic features with astonishing accuracy.
Once the pattern has been transferred, the protective coating is carefully removed, leaving the microscopic design permanently etched into the wafer.
Special atoms are implanted into the silicon, changing its electrical properties and allowing transistors to control the flow of electricity.
Each transistor acts as an electronic switch. Modern processors contain tens of billions of these microscopic components. Insulating layers only a few atoms thick separate different parts of the transistor, ensuring every signal flows exactly where it should. These steps are repeated again and again, building dozens of microscopic layers that transform a blank wafer into an incredibly complex processor. After each layer is built, the surface is polished until it becomes perfectly flat, ready for the next microscopic layer. These precise operations are repeated hundreds of times, with every layer adding more intelligence to the final processor. The AI flagged this cluster at sector gamma.
Confirming the parameters, it seems consistent with the batch anomaly from Tuesday.
Before a single chip is separated, every circuit is electrically tested to identify which processors meet the highest standards.
One finished wafer can contain hundreds of processors, each carrying billions of transistors on a surface no larger than a fingernail. Every chip is carefully mapped. Only the processors that pass strict quality standards continue to the next stage. Every chip is carefully mapped. Only the processors that pass strict quality standards continue to the next stage. Using diamond precision cutting, the wafer is divided into hundreds of individual chips without damaging their delicate structures. Each microscopic processor is carefully picked by automated robots, protecting components too fragile for human hands. The silicon die is mounted onto a protective package that allows it to communicate with the outside world. To control extreme operating temperatures, a metal heat spreader helps transfer heat away from the processor. After weeks of manufacturing and thousands of precision operations, the processor is finally ready for its final performance tests. Every processor must survive demanding stress tests, proving it can perform reliably under extreme conditions. Although they look identical, not every processor performs the same. The fastest chips are selected for premium products. From home computers to professional workstations, these processors perform billions of calculations every second. Today's chips bring artificial intelligence to our pockets, enabling smarter phones, robots, drones, and wearable devices.
Modern semiconductors guide electric vehicles, control satellites, and help spacecraft navigate beyond our planet.
Behind cloud computing, online banking, streaming, and artificial intelligence, millions of processors work together inside giant data centers.
The race never stops. Engineers continue pushing the limits of physics to build faster, smaller, and more efficient processors.
Artificial intelligence is now helping engineers design processors that would be nearly impossible to create using traditional methods alone.
The next generation of computer chips will power technologies that today exist only in our imagination.
It all begins with ordinary quartz sand, transformed through science and precision into one of humanity's greatest technological achievements. From communication and medicine to transportation and space exploration, computer chips quietly power the modern world. Hidden inside nearly every modern invention, computer chips have transformed the way humanity lives,